Welcome back. In my previous video I had seen limit superior and limit inferior of a sequence. Today I will see this topic also elaborately. At first I will highly recommend you, if you don't see my previous video, at first see the previous video. I have given the link in my description box. Then see today's video. Short trick to find limit superior and limit inferior is, let n be a sequence of real number and a be the set of limit point of this sequence. If a be the set of limit point of this sequence, then highest limit point is the limit superior and the lowest limit point of the set is limit inferior. So limit n tends to infinity n equal to limit superior of n equal to actually the supremum of a. Supremum, here a means set of all limit point, set of all limit point of the sequence n, and highest limit means supremum of the set a is the limit superior, and limit n tends to infinity a n equal to limit inferior of a n equal to infimum of a. Infimum of this set a is the limit inferior and supremum of the set a is the limit superior. Let's see some example, then you will understand in better way. First example which had come in CSIR net exam, which had come 16 September 2022. The question is, which of the given sequence satisfy the following identity? And equality is limit n tends to infinity limit supremum equal to minus limit n tends to infinity if infimum of the sequence an. That means highest limit point of the sequence is equal to minus times lowest limit point of the sequence. First, an equal to 1 over n for all n. At first see first option, then I will see second, third, fourth option. An equal to 1 over n, this is true for all n. Notice limit n tends to infinity, an equal to limit n tends to infinity 1 over n, which is equal to 0. That means the sequence an converges to 0. So limit superior of n as n tends to infinity is equal to, here limit inferior of an, limit inferior of an as n tends to infinity equal to limit n tends to infinity an equal to 0. So limit superior of an equal to minus limit inferior of n, because both are equal to 0. So option 1 is the right option. Next, an equal to minus 1 to the power n, 1 plus 1 over n, this is true for all n. Here the subsequence a to n equal to 1 plus 1 over n, this is converges to 1, and the subsequence a to n minus 1, this is equal to minus 1 times 1 plus 1 over n. This is, as n tends to infinity, this is converges to minus 1. Since the subsequence are converges to 1 and minus 1, so highest limit point of the sequence is 1 and the lowest limit point of the sequence is minus 1. So here also limit superior of an is equal to limit inferior of n, limit superior of an equal to here plus 1 and limit inferior of an equal to minus 1. So, this result here also satisfy. So, option 2 also right option. Notice option 3, an equal to 1 plus minus 1 to the power n over n. This is also same like second. Limit superior of an does not equal to minus limit inferior of an. So, option 3 is not true. Option 3 is not true. Here limit superior of a not equal to minus limit inferior of a. Option 4, an is an enumeration of all rational number in minus 1 to 1. Notice at first think oneself what is the limit point of this set. All rational number in minus 1 to 1 is minus 1 to 1 intersection q, which is countable set, and every real number r belongs to minus 1 to 1 is a limit point because rational number q are dense. Since they are dense, therefore every neighborhood of the set of R, every neighborhood of R contains infinite number of the points of the set. So, every point in minus 1 to 1 is a limit point. Not only minus open interval minus 1 and 1 also limit point of the set. So, set of all limit point is close interval minus 1 to 1 of the set. If denote the set as A equal to close interval minus 1 to 1. And supremum of A is limit n tends to infinity superior of an, which is equal to 1, and infimum of the set equal to limit n tends to infinity inferior of the sequence an, which is equal to minus 1. That means here condition limit superior of an is equal to minus limit inferior of an. So option 4 also right option. I hope my all viewers have understood now. Okay. Now I will see one question which had come CSIR 2018 June exam. The question is define a sequence an as follows: a1 equal to 1 for all n greater than equal to 1, and an plus 1, the sequence is minus 1 to the power n half times absolute value of an plus 2 divided by absolute value of n. Then which of the following is true? Option 1, limit superior of an equal to square root of 2, limit inferior of an equal to minus infinity, limit an, here limit of the sequence an is square root of 2 and supremum of an is square root of 2. Now let me show the which of the following is true. For notice at first, when n is even, then an plus 1 would be odd. That means this would be positive term, and when an is odd, then this part would be negative part. Then an plus 1 would be even when n is odd. So here an greater than equal to 0 if n is odd and an less than equal to 0 if n is even. Okay. Now consider the sequence here sum such type Sn plus 1 equal to half Sn plus 2 over Sn. Consider the sequence of positive term. If this sequence converges to alpha, then since this is the positive term sequence and when an greater than equal to 0 if n is odd, when n is odd, then if this is converges to alpha positive term and n is even, then n less than equal to 0. So when n is odd, if an converges to alpha, when n is even, since this means the an less than equal to 0, so obviously this is converges to minus alpha. So at first consider the positive term sequence as like consider an plus 1 equal to Sn plus 1, Sn plus half Sn plus 2 over Sn. Now notice this sequence converges to which point? If you consider am greater than equal to gm, then we all of us know Sn plus 2 over Sn divided by 2, this would be greater than equal to Sn times 2 over Sn, and this is nothing but this is equal to square root of 2. That means this means actually Sn plus 1, that means Sn plus 1 greater than equal to square root of 2. That means since this is true for all n, so Sn strictly greater than equal to square root of 2, this is also true for small or n, sorry. That means the sequence Sn is bounded above. Sn is bounded above. Greatest lower bound is square root of 2. Means the sequence is bounded below. So sequence is bounded below. If we can to see, the sequence is monotone decreasing sequence because the sequence, since the sequence is bounded below and least upper bound is square root of 2. So if we can to see the sequence is monotone decreasing sequence, then we can tell the sequence is convergence to the at square root of 2. That means sequence converges to greatest lower bound. Okay. Sn greater than equal to square root of 2. Therefore, Sn square would be greater than equal to 2 and 1 over Sn square it would be 1 over 2. That means 2 over Sn square less than equal to 1. Now write Sn plus 1 over Sn. Since Sn plus 1 means this and here divided by Sn, so divide this part by Sn, this would be half 1 plus, if you divided by Sn, 1 plus 2 over Sn square. And 2 over Sn means square root of 2 over Sn square. Here 2 over Sn square. 2 over Sn square less than equal to 1, then this value would be less than equal to half 1 plus 1. That means this is less than equal to 1. that means Sn plus 1 less than equal to Sn. This is true for all n. That means Sn is monotone decreasing sequence. So Sn obviously converges to greatest lower bound square root of 2. Sequence Sn convergent sequence and limit n tends to infinity Sn equal to L. Then since the sequence is limit n tends to infinity Sn plus 1 equal to limit n tends to infinity half Sn plus 2 over Sn. Since this is converges to L, so Sn plus 1 also, since the sequence is convergent sequence, that means Sn plus 1 also converges to L. That means this value would be L plus half L over 2 over L. That means this value would be 2L equal to L square plus 2 over 2. Sorry. L square plus 2 over L. That means this value would be 2L square equal to L square plus 2. That means L square equal to 2. So that imply L equal to plus minus square root of 2. This is the limit point of the sequence. That means sequence has, when n is odd, then notice n greater than equal to 0. So therefore when n is odd, then the sequence, the limit point of the sequence would be square root of 2, and when n is even, then an less than equal to 0. When an would be less than equal to 0, then this part would be minus half Sn minus 2 over Sn. So then the sequence converges to minus 2. So limit point of the sequence an equal to square root of 2 and minus square root of 2. So limit superior obviously square root of 2 and limit inferior would be minus square root of 2, but here given minus infinity. This is wrong option. Next, supremum of an equal to square root of 2 and limit of an equal to square root of 2. Is it true? Is when the sequence is odd, then the sequence is monotone decreasing sequence for odd, and the sequence converges to greatest lower bound square root of 2, and when the sequence would be even, then this part would be an always less than equal to 0. Then the sequence would be monotone increasing and the sequence converges to minus square root of 2. That means limit point of the sequence is square root of 2. This is not true. And supremum of an equal to square root of 2. This is also not true. Why? Because notice the greatest lower bound of the sequence is square root of 2. That means the sequence always would be greater than square root of 2. So option D also not true. Only option A is the right option. I hope my all viewers have understood clearly this question. Okay. Today I will stop here. In my next video I will discuss more another type of question about limit superior and limit inferior. Actually limit superior and limit inferior, this topic is very important for higher study, also for any competitive exam. Also I hope my all viewers have understood today how we have to find limit superior and limit inferior easily. Okay. See you soon. Stay safe and stay positive always. And don't forget to subscribe my channel for more videos. Thank you so much.